Hi, we're doing Saxon Math Course 2, and we're looking at Lesson 21. We're going to talk about prime and composite numbers, and we're going to talk about prime factorization. So what I want you to do is remember that what a prime number is. And so a prime number is a number that has exactly two factors, 1 and itself. So let's get started with our list of 16 prime numbers. Well, actually prime numbers that are less than 16. So as you can see, we have all of the numbers listed. I actually went further than just the numbers less than 16. We went up to 16. And what I did is I wrote down the factors of each of those numbers, if that's making sense to you. So what does that mean? So if I had to, as we say, factor 1, the only number that can divide evenly into 1 is 1. It just has one factor. That makes 1 kind of a special number. It is not prime and it is not composite. Because it only has one factor, it is special. So I'm actually going to take 1, I'm going to get my marker over here, and I'm going to kind of cross out 1 because it has nothing to do with our situation. It's not composite, it's not prime, so I'm going to just kind of cross it out and say, okay, it doesn't have nothing to do with what we're doing. However, now we come to the idea of prime. You see how I listed all of the factors down? So 2 can be divided by 1 or 2, 3 can be divided by 1 or 3, 4 can be divided by 1, 2, or 4. And when I say divided by, I mean divided by evenly. So check this out. Every number has 1 as its factor. Every number can be divided by 1. And a lot of numbers have a second factor. But the ones that only have 2 factors, those are prime. And so we want to keep that in mind. Let me get a brighter pen to make that very clear. So these numbers are prime. So 2 is prime. 3 is prime. It only has 2 numbers that can divide into it evenly, only 2 factors. 5 is prime. 7 is prime. Keep going. 9 isn't. It looked like it might have been, but 1, 3, and 9 are factors of 9. So 9 is not prime. 11 is prime, and 13 is prime. And that's it for the numbers that are less than 16. Those are our only prime numbers. So those are prime. The other numbers that, aside from 1, we're not talking about 1, the other numbers that are not prime are called composite. So let's go ahead and make a little key here. This means that they are prime if they're this color, if I've got them highlighted with that yellow, and if I have them highlighted in, let's say, red, then that's going to be composite. And you can see most numbers, the more numbers we get up to, the more numbers we use, you're going to see most numbers are composite. So prime numbers are a very rare type of number, okay? And composite numbers, let me write composite here. Composite numbers you see quite often. 1 does not fit in either of those categories. So here in example 2, we're asked to list the factor pairs for each of these numbers. Now, I like to call them factor rainbows because I like to make a rainbow out of it. And we talked about that before. So if I have, let's say, the number 16, and I want the factor pairs, I know 1 times 16 will give me 16. I know 2 times 8 will give me 16. And I know that, 4 times 4 will give me 16. So I could put 4 and 4, but I'm going to just leave 4 right there. And I'm going to make a little corny rainbow out of our situation. All right. So I see 2 goes to 8. And then I see 1 and 6 goes together. 1 and 16 rather goes together. So I have that. So that's my little factor rainbow. Let's go ahead and make a factor rainbow for the next one. So the next number is 17, and my factor rainbow, or my list of factors, let me use a proper pen. I used the wrong thing here. So my number 17, if I think about numbers that multiply give me 17, I know 1 and 17. 2 doesn't go in there. 3 doesn't. 4 doesn't. 5 doesn't. 6, 7, you see where we're going. It's a very sad rainbow. 17 is a prime number. Let's go ahead and do our next factor rainbow. So our next factor rainbow is 18. So 1 and 18. I know 2 and 9. I know 3 and 6. And I think that's it. 4, 5. Nope, none of those work out. Okay, so I'm going to go ahead and make my rainbow. So here I've got 1 and 18. And I think the rainbow is just fun for me. So it's not like that is required. But what it helps me to do is it helps me to remember that either the number is being multiplied by itself, like 4 times 4 gives me 16, or it helps me to like make sure I've got all the factors. So the factors of 16 are 1, 2, 4, 8, and 16. The factors of 17 are 1 and 17. The factors of 18 are 1, 2, 3, 6, 9, and 18. So this next problem, example 3, asks us to list the composite numbers, not the prime ones, but the composite numbers between 40 and 50. So really, at this point, we could really list the prime numbers, cross those out, and the rest are composite. All right, so they said between 40 and 50, so I'm going to just gently scratch out 40 and scratch out 50 because they're not a part of what we're concerned about. And so really what you want to do is think, do you know two numbers other than 1 and that number that will multiply to give you 41, 42, 43, 44, 45, and so on? Now, the first thing about composite numbers, after you do 2, like after the number 2, all even numbers are composite. I'm going to say it again. After the number 2, all even numbers are composite. In fact, the only prime even number is 2. All even numbers, aside from 2, are composite. So that makes our lives pretty easy. I know that 42 is even, 44, 46, and 48. I get that from skip counting. I get that from knowing my multiplication tables. So I don't got to worry about these. These are definitely composite. When I look at 45, I see that it ends in 5. And I know any number that ends in 5 or 0 is divisible by 5. So I know that this is composite as well. Meaning I know that another number divides evenly into this other than 1 in itself. Now these tricky ones, 41, 43, and 47. Kind of hard. You can kind of think about it. You can kind of think, okay, are there any numbers that divide in there? Now, I already know the answer to this, but what I'm thinking about is how am I going to get somebody who doesn't know the answer to this to figure it out? You can do something which is to divide by numbers going up to about the halfway mark. So if by the time you get to about the number 20, you don't see any number that divides evenly into 41, then you can be sure that no number divides evenly into 41. So we know 1 goes in there. That's not impressive. 2 does not. It's not even. 3 does not. There's a clever test to use for 3. If you add up all the digits of a number, so 4 plus 1 is 5, if 3 can go into that number, then 3 goes into the number that you were talking about. Since 3 does not go into 5, 3 does not go into 41. That only works, by the way, with 3 and with 9, but we'll talk about that later. So 3 doesn't go in there. 4 doesn't because it's even. An even number can't go into an odd number so evenly. So 4 doesn't work. 5 doesn't work because it doesn't end in 0 or 5. 6 doesn't work because it's even. 7 doesn't work because it's not in the 7 times table. 7 times 6 is 42, not 41. So I know 7 doesn't work. 8 doesn't work. It's even. 9 doesn't work. It's not in the 9 times table. 10 doesn't work because it's not ending in 0. 11 doesn't work because 11 is like 44, 33, those types of numbers. 12 doesn't work, it's even. 13 doesn't work because the closest number that gives you 13 is 39. Like 13 times 3 is 39, and that won't get to 41. 14 is even. 15 doesn't work, it doesn't end in 5. 16 doesn't work, it's even. 17 doesn't work because by the time I get to 17 times 3, I'm at 51, so that's too big. 18 doesn't work because it's even. 19 doesn't work because 19 times 2 is going to be 38, which is close. So another 19 is going to throw it over. And then 20 doesn't work. And so we know that this is prime. I know that seemed like it was time consuming, and it kind of was. But that's how we can determine our prime. So without further ado, I'm going to circle these and let you know that they are indeed prime. All right, let's look at another example. So here we're supposed to do prime factorization for each of these, and I'm going to show you how that's supposed to be done. So you take your 30 and you find two numbers that multiply to give you 30. I like 5 and 6. And if one of those numbers is prime, you can circle it and stop that chain. But if it's not prime, it's composite, you got to keep breaking it down. So when I break down 6 as 2 times 3, and I know that 2 and 3 are prime, I know I'm done. So the prime factorization of 30 is equal to this. I'm going to go from least to greatest number, multiplying 2 times 3 times 5 gives me 30. So that's the prime factorization of 30. Let's try 81. So if I break down 81 in two numbers, you know I like 9 and 9. That makes me feel good. But when I break down each of these 9s, because neither of them are prime, I get 3 times 3 times 3 times 3, which 3 times 3 is 9 and 3 times 3 is 9. And both of those 3's, or all 4 of those 3's, are prime. And so now I've reached the prime factorization for 81. So when I write that down, I'm going to write, let's use a different pen, I'm going to write equals 3 to the 4th power. Why am I writing 3 to the 4th power? Excellent question. I'm writing 3 to the 4th power because we know that 81 is 3 times 3 times 3 times 3, according to our prime factorization. And we can write that as 3 to the 4th power because that's 4 3's being multiplied together. All right. So our next one that we got to do is 420. Let's go ahead and bust that down. It looks like it's going to take a long time, but we're tough. Easy, cheesy, Febreze. Watch this. 42 times 10 gives me 420. So I'm going to scooch that down a little bit. I know that 42 comes in the 7 times table. So that's 7 times 6. And I've already got 1 prime. So that's good. Let me keep with this 6 real quick. I'm going to break that down into 2 times 3. I've got 2 more primes, and now I've got to work on my 10. What two numbers multiply to give me 10 other than 1 and 10? 2 and 5, and you know it, they are both prime. And so now I've got the prime factorization of 420. What I'm going to do is do it in order: 2's, then the 3, then the 5, then the 7. So I got 2 2's, a 3, a 5, and a 7. And I'm going to write that more conveniently as 2 squared times 3 times 5 times 7. I hope that's making sense, sweetheart. All right, we're going to look at another example. Okay, so we're going to prime factorize 100 and the square root of 100. That's what we have to work on here. But the square root of 100 is really just 10. So now let's break down 100. We know that 100 is 10 times 10. We also know that 10 can be written as 2 times 5. And there it is. We got to our prime numbers. So I'm going to highlight those 2 prime numbers, and we're going to keep it moving. Break down our 10 to 2 times 5. Highlight those prime numbers. And so I see that my prime factorization of 100 can be written as 2 times 2 times 5 times 5, which I'm going to write as 2 to the 2nd power times 5 to the 2nd power. So now that we've done this, we could do this guy. It's easy. They tricked us, make us think that it was hard because they did the square root of 100. But really all we're doing is doing the prime factorization of 10, which is going to give us 2 times 5. We're going to highlight 2 and 5 because they're prime, and we are done. Excellent work. So 2 times 5 is all we need here. This next opportunity gives us a chance to take a look at prime factorization of 2 numbers. So we're going to prime factorize 36 and we'll prime factorize 60. And then we're going to use the results to find the greatest common factor between 36 and 60. So let's take a look at this. When we prime factorize it, again, we're breaking it down into prime numbers. 36 is 6 times 6. That breaks down into 2 times 3, and then again 2 times 3. So I'm going to write it as 2 times 2 times 3 times 3. I know I could write it with exponents, but I'm going to hold off on that for a very specific reason. Let's take a look at this one. Let's prime factorize 60. So we have 6 times 10, and we can break that down as 2 times 3, and break that down as 2 times 5. I'm going to highlight my prime numbers. Let me get back in here. I'm going to highlight my prime numbers in order just so we can see what's going on. So once I highlight those, I know exactly what each of these things is made out of, all right? So again, I'm going to write them out in a way that I didn't before without the exponent. So watch this. 2 times 2 times 3 times 5. Nothing interesting there. But we need to find the greatest common factor. And to do that, all we have to do is look at what they have in common as their prime factors. So notice they both have 2 2's and a 3. 2 2's and a 3. That will be their greatest common factor. So to find their greatest common factor, I know it's 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. 12 is the greatest common factor here, and that's what we're looking for. Now you are ready to do your written practice, and of course your practice set. Do all of those, do the odd ones of these, and make sure, of course, you read through the even ones because they will appear on your tests. Take care.